Guys, this is number 5 from the last worksheet. So someone is asking a couple of questions, so let's do it together. F squared is that. Agree?
Yes.
And the technique I ask you to use is such that take elements. So usually when I do this as a student, I like to leave some space in between them. There's a reason for the space. I take elements in the first row, right? As you have been advised. So it's like row by column pattern, right? So 1, 0, and 1 here. You take this first row, you bring it here. Okay? If you distract my class, I kick you out. Okay? So you multiply in that order. So again, from the first matrix, you pick from the top or from the bottom. From the second matrix, you multiply to the left or right. So when you take it from the top and you multiply the left, your answer will be in the top left. If you take it from the top, you multiply the right, because when you bring it here, it's going to be here, right? And you multiply the right, your answer will be in the top right of the resulting matrix. If you take it from the, now when you are done with that, you take from the bottom now. So bottom times left will be in the bottom left, bottom times right will be in the bottom right. So that tells you the position of the result. Do we remember that?
Yeah.
Okay, so we take it from the top now. You're taking it from this, you're multiplying by this. So if you take it from the top and you multiply the left, this is right. Multiplying by this means this times this, just the way you place them. 0 is at the end of this arrow, 1 is at the top of the arrows. You can see 0 is at the end, 1 is at the top. There's no magic here. So 0 times 0 plus 1 times 1. Okay? So now top, multiply left. So the same top, before you raise it, you multiply the right. 0 times 1 plus 1 times 1. It's always easy that way. It's just like copy and paste stuff. So now this is gone. Now you take from here, you have 1, 1. Right? So you do 1 times 0 plus 1 times 1. Okay? I know most of you have done this. I'm just trying to re-explain. 1 times 1, 1 times 1. Can somebody check the aircon? Anika is freezing. I never knew Anika was from Africa until now.
Check the aircon.
What temperature is that?
21. I put it up to 23 and I
Where was it before?
21.
21 is freezing for you?
I checked.
Or another theory could be, maybe her real name is not Anika. Maybe her name is some, give me some African name. Chichumba or something. Who knows? Alright. Okay, look up now. So this is 1, this is 1, this is 1, and this is 2. Correct? The next question I ask you to do is find F3. So F3 means F1 times F2, right? So 1, 1, 0, 2, no. Multiplying, what's the first one? No noise, please. That's going to be F3, right? So that's F2 times F1. Or it could be the other way around. But the thing is this the same result? Because normally, when you multiply matrices, you don't get the same result if you rearrange them, right? So for this to hold, it must be that you get the same result. So in this case, the matrices are, there's a word for it. If you do, I'm asking you this question now. 2 times 3 is the same as 3 times 2, right? So what do we say about multiplication?
2 times 3 equals 3 times.
Just pretend this is 2. Okay. So there's a property. Multiplication is said to be what by this property? Do you remember?
Reverse. Even if you change the reverse.
I'm looking for a word, not an explanation.
Reverse?
No. There's not an identity. It's not in your book.
No, I think
Bilingual? Have you heard about C O
converted.
Communication.
communism?
Commute.
Yeah, something like that.
Communication. No.
She said commute.
Commutative.
Communication.
Commutative. What? Commutative.
So when an operation is commutative, it means when, listen. Okay, sorry I had to do this. What's different between operation, Joey? Check, be sure. So that when we see this later, everybody knows what we're talking about. What's different between operation, operator, and operands?
Operations.
I give you 3 plus 2. Explain. Wait. Who's ready?
I'm ready.
Me.
Iron Man is ready.
I'm ready, yeah.
That's we're dead in Avengers.
I haven't watched it
You
yet.
haven't watched it? Oh, well. You just RIP stuff, okay?
Also, a couple of other people also died.
Wait, Iron Man wasn't the only one that died,
I
okay?
haven't watched it.
Oh, yeah, nah? Oh, sorry about that.
Watch it though.
Spoiler alert!
No, I'm from a different universe.
Oh, yeah, sorry. This is a different Iron Man.
You're from a different timeline.
Yes, timeline.
Yeah, different Iron Man. Okay, Jamila, so it's not entirely spoiled. Just pretend this is Flash. So this is a different Iron Man.
You can't compare Marvel. Sorry.
Quickly. Okay, so Mr. Iron Man.
The operation is the whole thing.
What do you mean the whole thing?
Operation is 3 plus 2.
So what is the word? What operation is this?
Addition.
Addition. Good.
No.
Yes. Oh, okay.
Yes.
Okay. All right. What about the other two?
Numbers.
The symbol.
Plus 2.
The symbol.
Oh, and then operand of numbers.
3 and 2.
Operand is 3 and 2. Smart
See,
student.
I'm smart.
Smart student.
Sometimes.
Smart.
No, it's not 3, 8 with a line 2.
And it's on your keyboard. You have this, right?
Mr. Daniel.
No, I
No.
You can sue me, okay? This is how I want to write it.
Follow the finger.
You add another line in the dollar symbol.
Dude. You see, there's a more civic way to go about this. We don't have to argue. Petition United Nations. Tell them this is how I write my hand. Period. Okay, quickly now. Yes, ma'am.
Why have you started writing your twos differently?
Why what?
You're writing your twos differently.
Is this your problem now? Okay, quickly. Now, listen. Enough of that. If I change this to 2 plus 3, happy now? Okay, good. If I change this to 2 plus 3, does it make any difference?
No.
So why do I always say this operation, which is addition, is commutative? Because irrespective of the arrangement of the operands, the result remains the same.
Yeah.
The question is subtraction commutative?
No.
What about multiplication?
Yes.
Oh, yeah, what about division?
No.
That's it. So binary operations have certain properties. One of them is commutative property. Okay? Or could have certain properties. Now in matrices, we have seen that is AB necessarily the same as BA?
No.
Talk to me. Is it?
No.
No. Even sometimes the order will change. AB could be 3 by 3, BA could be 2 by 2. Do you remember the question?
Yeah.
There was a question we did. AB and BA, not only are they different matrices, they have different orders. So for all matrices, this is not always the case. But some situations, this will be the case. You can give me one situation where AB is the same as BA.
A is 0, 0, 0, 0, and B is also
So if you have a zero matrix, so zero matrix and any other matrix times zero matrix will give you 0.
Yeah.
Okay? What about another example? Identity. So you can have IA is equal to what? AI. These are special cases where commutative property hold. Joey, that thing, put it in a way that you can see. The view, yeah. So you don't have to. Alright. Does it make sense? So now, so my question is, did anybody bother to check if these two matrices can satisfy this property? Did anybody check? Because if you do F3 and somebody did F squared times F, and someone else did F times F squared, both of them is F3, right? So we need to be sure if commutative hold. If it is commutative, then we don't have any problem. So let's see what happens. So take this and bring it here, we have 1, 1, right? Okay, so I get 1 times 0 plus 1 times 1. Okay, then the other one will be what? 1 times 1 plus 1 times 1. Isn't it?
Yeah.
Then we take the second row, 1 and 2. I need your attention, not conversation over there. Take the second row, what do we get? 1 times 0 plus 2 times 1. Yes?
1 times 1, 1 times 1. Oh, 2 times 1.
So what does that give us? So you have 1, 2, 3. So let's see what happens if we change the order. 0, 1, 1, 1, 1, 1, 1, 2. Okay, so when this goes here, you have 0 and 1. So this is 1, right?
Yeah.
This is 2. So we put the 1, 1 now. This is 2. This is 3. So it's right.
Oh.
Did you not do the work, please?
What?
Okay.
Don't do that next time.
Sorry.
Thank you. Now, let's see F4 and do our comparison. F4, easiest way, can do F2 times F2. Just square F2. Or you can do F3 times F1. Okay? So, F2 times F2, 1, 1, 1, 2, 1, 1, 1, 2. Here you don't have to worry about commutative, right? Because they are both the same anyway. So, let's move. So we take 1, 1 first. Agree? So that's 1 times 1, 1 times 1. The other 1 times 1, 1 times 2. Now we take 1, 2. Am I too fast? It's okay?
Carry on, yeah.
Alright. So the other one will be 1 times. Now this is 1 times 1. This is 1.1. Two different things. If you type on the computer and you put 1.2, you always see that the dot is here. Okay? So if you mean multiplication, put it in the middle. Okay. I used to write my 1.1 like this. Anyway. So you know I've also messed up in the past. Just telling you. Alright, 2 times 1, then the last part, 1 times 1 plus 2 times 2. So what do we have now? 2,
3.
So F4 is 2, 3, 3,
4, 5.
5.
4.
They were just drunk at that moment. But they are fine now.
We were doing the words out loud. We're drunk on math.
Alright, listen. Now, let's see. Observation. What is the observation? So let's check the entry A11. Entry A11, what would we have? 0 for 1. Then for 2, that's 1. Can you see?
Yeah.
For 3, you also have 1. Then for 4, you have 2. So what's the next one? So 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. Then the next one will be 5. So for the next entry, which is F5, there's no space. Okay, you get out. F5 and FC. This is what I ask you to predict. Do you understand?
Yeah.
So for the first entry, this one will be what? 3, and this will be 5. Now, let's check again. We notice the non-leading diagonals are the same. 1, 1,
Oh, yeah.
1, 1, 2, 2, 3, 3. Oh, this is the last one. So let's see. Non-leading diagonal, we have 1. For square, it's also 1. The next one is 2. And the next one is 3. This is another Fibonacci sequence. Do you know what I mean by Fibonacci sequence?
5.
No. I like to.
If you had this, if you had 2, you get the next one. So this plus this, these 2 give you that. So what's the next one?
5.
What's the next one?
6.
So this must be 5, 5. This must be 8, 8.
Oh, wow.
Okay? So let's see the last entry. That is entry A22. The one we just completed is A21 and A12. Do you agree? Do you remember what I mean by entry AIJ?
Yeah.
Does anybody remember entry AIJ?
Yeah.
Good. Okay. Okay, so the last one we have 1, then 2, then 3, 5. What do you notice? Fibonacci again. So pretend this one is 0, so 1 plus 2 is 3, right? No, this will have to be like 1.
Yeah.
So wait, 1, 2, 3. So 1. Okay, there's nothing here to justify this one. But we know 1 plus 2 is 3, 2 plus 3 is 5. So we have 8 and what?
8 and 13.
8 and 13.
It is 21.
Who got that? Who made mistakes? Alright, if your worksheet is here, you can have it and fix your mess. It's not my mess, it's your mess.
No, I didn't get it.
You didn't get
We
what?
have exam on Friday, so we didn't get the work.
Oh, okay.
I did.
Quickly, begin my class. So check here. Do you have this? Alright.
I'm pretty sure I don't have it.
Yeah, pick one.
No way!
Is that me? That one.
Oh, Tree asked me to tell you.
What's that?
Yeah, about your shirt. Oh, yes.
Well,
Is that like a style?
It's
Is it just that?
It's like half tuck, half tuck.
Yeah, like
Mr.
50%.
Daniel, every time you turn around, she's like, oh!
Well, that's allowed. Alright, quickly. So let's go into determinants. So this will help some of us. For anyone who didn't meet some of the things we did, I would rather you take that off the table, ladies. Because we are here to do something important of us. So determinants is what we are here to do this first lesson. And of course it will take us to the next lesson, next period. Determinant only exists for square matrices. Okay? Remember at the beginning, I asked you to use 2 types of brackets, right? Do you remember?
Yeah.
This and this. And I told you something is not allowed. What's that? You just draw a line. Because this represents determinants. Okay? So let's begin with that. So you might want to write 1 or 2 things down. For your IGCSE syllabus, you are only required to learn 2 by 2. When you move to higher grades, you learn 3 by 3 and maybe higher determinants. Higher determinant doesn't exist in high school, so forget about it. So for matrix, I write the matrix as A, maybe the elements are A, B, C, D. The determinant of A, we denote it by either that modulus sign, that vertical stuff, or DET bracket A. So if you see something like DET bracket A, at my level of study, we hardly use this. This is what we use at my level of study. Okay? Or DET bracket A is given by determinant of A equals, you change the square, the brackets to that, and what happens? It's like a cross multiply. You multiply the elements in the leading diagonal, and you subtract the elements, the product of the elements in the other diagonal, and whatever you get is the determinant of that matrix.
Wait, was that before the bracket?
Can you see from the back, Kelly? Just one.
I don't understand the word before by.
Before by, given.
No, the other
Oh,
line.
no.
The second line.
Denoted.
It's denoted, denoted. Sorry, handwriting is messy.
What's that?
Or
Or
what?
DE, I'm telling you, these are the symbols that we use. We don't need to write determinant of A as a word. So these two symbols represent determinant of A.
Is it debt?
DET, yes. We don't call it debt. People might be scared.
Debt is DEB.
People might be scared.
Debtor.
You're going to remind somebody of Iron Man.
Pew pew.
No, it's too soon for this.
I never said anything.
Too soon? It's been like how long? 2 weeks now.
Exactly.
Oh, wait, have you seen the movie?
Of course.
So you're still crying? Sorry.
It's sad, okay? It's always happened for 11 years.
Are you gonna throw away your
It's
big
almost
now?
And you know, Mr. Daniel,
Yes.
when they were going to film they, all of the actors were told it was a wedding. And then they showed up and they're like, hang on, where's Robert? Like when they were seeing you already know, when they were filming the funeral, all of the actors that showed up, it was a wedding.
I didn't know they said that.
Oh, so they didn't actually know?
She watched YouTube and YouTube
When they were filming, I don't know.
So they didn't know he was dead in the scene?
No, they didn't know. And then, like, after they arrived, and he wasn't there, and everybody else was there, they figured it out. But also, one person also noticed that the other person that died, don't say who it is, wasn't there, and thought that they were getting married. It's just like, what? Why would they be?
I need to watch this interview. Anyway, yes, quickly. What do you mean brackets? This one?
It's all your head.
No, it's a straight line, this symbol.
I mean,
Quiet please, quiet please. Alright, let's get things together now. Now, this determinant will definitely give you a number, not a matrix. If that number is 0, we call this matrix a singular matrix. That's what I mean by singularity. Okay? Not like singularity could be any other thing in math anyway. So if determinant of A is equal to 0, then A is a singular matrix. Of course, if the determinant is not 0, then it is non-singular matrix. Now, I'm going to remind you of this even when we get to inverse. Okay? Because I'll be telling you at that moment, the inverse of a singular matrix does not exist. We'll tell you why, maybe later today or tomorrow, depending on how fast we are. Okay, so let's just do some. The rest of the work is just you working. So I'm just going to give you 1 or 2 examples. Let's see if the question says find the determinant of maybe the matrix. So the matrix will be written in matrix form, not when you're about to find out your determinant, you change the symbol. Okay? So let's see 1, 2, 3, 4. Everybody, please pay attention. So I want to find the determinant. So this is a matrix. This is not determinant yet. So I do not expect anybody to write. They're not listening now. They're probably going to do that. I do not expect anybody to write 1 times 4 minus 3 times 2. Can somebody tell me what is wrong here?
That's implying that x is equal to 1.
Thank you. Say that louder, please.
It implies that x is equal to 1 times 4 minus 3 times.
So if you get your answer to be -2, it means you're implying that x is -2. X is a matrix, not a scalar. Do you understand? So I do not expect anybody to do. That's why I ask you to stop writing and pay attention now. Before I give you a paper, out of 50 you get to it, I'm like, oh, did I do wrong? I'm going to take my money.
What?
Yeah, they are all mommy's babies anyways. And daddy's babies. Anyway, so this will be 1 times 4. Can you see what I did?
Yeah.
So now I'm finding my determinant. Of course you can write here. 1 times 4 minus 3 times 2, and that is -2. Does it make sense?
Yeah.
Yes?
why do you need this? Why do you need determinants?
I'll tell you very soon. We need it for inverse at least. That's the first one. And why do we need our inverse? It enables us to solve higher problems. Okay, if I give you something like 2a plus 3b minus 5c plus 10b plus 11e is equal to some number, and I give you 5 different equations, it might be something more tedious. We can use matrix method to do it. We call something Cramer's rule, and determinant comes in handy. Anyways.
Sounds like grammar rule.
Yeah, I think his first name was Gabriel or something. Sound like Iron Man. Anyway, so okay, let's see why. Okay, can you do this for me? 1 1 3 3.
Okay.
1 1 3 3. What's that? What's the determinant of that? If you are done with Y, check B. Check determinant of Y, check determinant of B. If you've done Y, raise your hand. Okay. Okay, write a comment what you notice about Y.
It is.
Write a comment what you notice about Y. You know what I mean by the comment, right?
Yes.
Good. Giselle, are you confused? The comments? Have you done Y?
Oh,
Have you done Y? Okay, so what do you get? Yeah, so what does that mean about, what does that say about matrix Y? Oh,
What, that's a determinant?
oh.
That's a singular matrix. Yeah.
Yeah, I think it's singular.
Oh, the answer.
Oh.
Why is a singular matrix?
Poked out.
Oh my God.
Thank you. Oh.
Quiet, please. Try that. Wait a minute. What did I just do? Yes, sir.
Do we have a break after these questions?
Oh, is it time? This is 46. Our break is 47.
just 1 minute.
So our break is less than 3, 2, 1 now.
Now.
Our break is now.
Yay!
3 minutes break. Wait, can we finish this? Then I can give you a break.
But you have to make it 5 minutes.
Yeah, whatever.
Oh. And then
I mean, like, yeah. All right, let's finish this. After this.